Hi, I'm Dan, and I do astrophysics. But when I was a kid, I really wanted to be a professional basketball player. That is until one day I had a doctor's checkup, and the doctor measured my height, and he put the number on this chart that had these different growth curves, and he followed the curve that I was on, and he said, when you grow up, you're gonna be 5 feet tall. Now, I hope you're thinking that the doctor is the only reason I'm not a professional basketball player. But that question has actually been the key question in my research, the question of, do those curves make any sense? What I research is the size of the universe. I work on a team that uses the Hubble Space Telescope to measure how big the universe is today as an adult. The way we do this is by measuring supernovae. These are exploding stars. They explode the same way every time, and they can be used as measuring sticks to different parts of the universe. So we have a measurement of the universe as an adult, and there's another team which is funded by the European Space Agency, and they have a measurement of how big the universe is as a kid, just shortly after the Big Bang. The way they can do this is that we're still able to see the light that's scattered from the Big Bang. So they have the measurement of the universe as a kid, and we have a measurement of the universe as an adult, and there's a curve, which we call the standard model of cosmology, that should connect the two. Now the problem is, if you take the measurement of the universe as a kid, and you follow that curve, what we see is nowhere close to what my team actually observes. So what's predicted is nowhere close to what my team actually observes. So there's 3 things that could be going on. 1, my team messed up. 2, the European team messed up. Or 3, maybe that whole curve is wrong. Now this has gotten a lot of scientists very excited because that curve is based on an assumption that most of the universe, 70% of the universe, is made of dark energy. Now dark energy is like the energy of empty space, and our best theory for it goes back to something that Einstein came up with 100 years ago. Now, it's possible that the 2 teams aren't wrong, but actually aren't wrong. It's actually that Einstein is wrong. Now, Einstein's like the last guy on a court you ever want to trash talk. But it's now gotten to the point that maybe he is wrong. So, if in the future you ever have a kid or the center of your universe who goes to the doctor's office and realizes that maybe he or she will not be a professional athlete when he grows up, or she grows up, tell them that that's okay, because the biggest mystery of the universe is still theirs to discover. Thank you.
How convenient to just blame it all on Einstein.
Yeah,
Jeez.
always.
So the standard model of cosmology, that's what connects juvenile universe size to adult universe size. And so you're saying that maybe it's not so standard after all?
Right, so we call it the standard model because basically it's like a rule in science where if you're really confident in it, you want to just give it the most boring name possible. But the truth is there's a lot of assumptions in the standard model that might not be right, and we're just starting to really test it and really have the observational evidence to see how good it is. So standard means we're confident, and I think that confidence is starting to wane.
Go ahead.
So it's not a slam dunk then.
Not a slam dunk,
Sorry, could you, I'm a scientist, not a comedian. Could you say just a little more about how they determine the size of the baby universe from that early radiation? I didn't totally get that.
Right. So I could definitely give you an answer, and it will make you more confused, if that's okay. Okay, so the universe may be infinite, and it's actually impossible for us to say, like, here's the ends of the universe, because that doesn't really have any meaning. So what we actually talk about is what is the scale of the universe, and it's like if you have a map, and there's that scale that says 1 inch equals 1 mile. When we talk about how the universe is expanding, is that scale is expanding. So going back to the Big Bang, we're able to look at signatures of the light that's scattered when the universe was very hot, and it allows us to place a scale on how big the universe was. But kind of saying, like, it's this big, we can't do, but we could say kind of what is the scale of it. And I know that's not.
That helps.
Yeah, okay, thanks. Yeah.
Yeah, because, see, I'm thinking, using your analogy of the doctor's office and the growth curve,
Yeah.
I'm thinking that there's a growth curve that goes up for people, and then when your mouse runs out, you start, going back down this way.
Yeah.
So is that going to happen with the universe, or is it?
Right. So the question actually rests on what is this dark energy? And if it turns out that dark energy is kind of growing in strength, then basically the universe is just going to end where everything is pushed apart from everything else and it all freezes. And that's kind of what's going to happen next. But maybe dark energy just shows that we don't really understand gravity. And if that's the case, then maybe what happens to the fate of the universe is something totally different. So kind of our measurement of what this mystery is will tell us what's going to happen next. Great.
Thanks, Dan.
Thank you.